All right. Hey everyone, welcome to week 5 of our beginner track. So yeah, if you guys don't have the slides yet, check out this link. It'll be fixed by later, but you guys all have the link already. If you're following along on the Acm membership portal, the code for this week is Croatia. This is like the second to last week, so if you guys can think of the pattern between all the codes, now it might be a good time to think about it. It's a pretty cool pattern in my opinion. And I guess the hint for the pattern is sports. It's really something sports related, so that's pretty cool. And last week we did the Discord, and on the Discord we like post like a link to the recording of the video of the workshop and like reminders about the workshop as well, and answer any questions you have. So if you haven't already, I recommend joining it. All right. Also, we gotta say today's topic is Numpy and Pandas, two really important data science libraries that we're gonna talk about a bit, and like hopefully by the end of today, get everyone pretty familiar, or at least introduce everyone to these two libraries and like the basic functionalities of them. All right, but before that, we're gonna talk about a cool event from Acm Ai Events. So this is the second event of the quarter for them. So that's pretty awesome. But this is a not so technical workshop, and so I know you guys are all thinking like you are pretty technical now in beginner track, but there's always something to learn non-technically as well. And this is actually a pretty cool way to learn about AI techniques and concepts and applications, in like a pretty conceptual and not super like technical like math or like coding oriented manner. And so I think it's pretty cool. I put the links to both the event and the RSPV link in the slides, so you guys can all check that out. It's on Monday, May 17th from 6 to 7. So pretty short, but pretty informative as well. Yeah, it should be recorded. So yeah, it should be, I think it'll be posted on the Acm Discord. I'm pretty sure the recording as well. So it should be on the Facebook event as well. So yeah, so it looks pretty cool. Definitely recommend at least checking it out, like looking at the Facebook page and seeing what's happening. Or if you can't make it, check out the recording of it as well. But yeah, definitely would recommend this. All right. With that, we're gonna actually dive in immediately into the coding section, because Numpy and Pandas are kind of hard to like explain with like slides, because it's just like typing out like functions that they have. And so we're just gonna dive right into like an actual like coding section. So just like week 1 with Jensen, I'll be like we both be like live demoing code. And so feel free to follow along by making your own Google Colab file. And then like I don't know what we're doing. I don't know what I wrote here. This is a typo. Step 3 is a typo. But it's probably should be like this should probably say like make a Colab file. And then after that, like check out what we're doing, and then like try writing it and try making some changes to it as well, so you can like play around with our code as we're doing it. And so that's kind of the goal. So like make your own file, like play around with the stuff as like while we're guiding you through it. All right. And later we'll get into this worksheet, which is kind of like a revision of everything we go over. So that should be pretty cool. But with that, let me open my NumPy notebook, or my Python notebook, so we can get started with that. But yeah, okay, cool. So first things first. All right, hopefully you all have your Python notebooks open on Colab. So with that, first step is very important. It's an import NumPy. So import NumPy as NP. So typically people import as NP because it's just more simple. It's simpler like that. So that, go ahead. We just made this, so yeah, run it anyways. All right. Why is it taking so long? I don't. Okay. Awesome, it worked. So I imported. That shouldn't have taken that long, I think, but it's okay. Nonetheless, first, before I dive into stuff, I want to quickly talk about what exactly NumPy is, like in a bit more detail. So NumPy is like a really useful library for like dealing with like matrices and vectors and all that stuff, and like handling them in general. So it's probably the #1 way I've seen matrices and like matrices represented, as well as like manipulated in machine learning code. And so it's definitely worth learning because like most code uses NumPy. If it uses Python, it uses NumPy. So definitely recommend. But with that said, let's first talk about how to make an array, because if NumPy is all about arrays, you need to figure out how to make an array first off. So they actually give you many ways to make an array. So let's start out by like defining our first array. So let's say array 1. So many ways to make an array. So we can just like type in numpy.array, and they'll actually tell you how to make an array. And so this function is the easiest way to make an array, or one of the easier ways to make an array. And so the way it works is that actually the only parameter is an object, which is kind of vague, I would say, but it's any object with the array interface, which is also really vague. But the main point is that anything that looks like an array can be inputted here. So what do we have in our disposal that is like Python-like and also is look like an array? It's a list, for example. So we can input a list right here. So let's do like 5, 6, 7, 8. And then if you print out array 1, it ends up being a NumPy array. So this is our first NumPy array. Pretty awesome, right? And so it doesn't just stop there, because this is just like a list right here. So it's just like kind of boring. But let's make it a bit more interesting. It doesn't just have to be a one-dimensional array. It can be like 2-dimensional, 3-dimensional, n-dimensional. So let's do like 5, 6, 7, and then like 8, 9, 10, and then like onwards. 1, 2, 3. Not in order anymore. That's okay. But this also works. And you can see now we have a 2-dimensional array. It's actually, 2-dimensional array, 3x3 array. So 3 in each dimension. And so that's one way to make an array. And so with this structure, you can make arrays that are kind of custom to like your inputs. And so like if you already know what data is in your array, or you already have like a list or a list of lists that are like ready, you could input it into numpy.array, and that should give you your function that you want. Any questions about that part? All right, cool. I'll move on. Feel free to stop me if you have any questions. But if you might notice that this is kind of limited, because this forces you to know your data in advance, as well as like input it like manually in here. So like if you have like a 1,000 by 1,000 array, you're not gonna want to like type out like all 1,000 elements 1,000 times, right? So NumPy has a lot of ways to make arrays that are pretty fast. And so you're probably familiar with the Python range command. So I think Jensen talked about this week 1, but you type in like range 10. Oh, forgot, range is a little bit weird, but type in lists of range of 10. You get like all numbers from 0 to 9. And so basically it's like starting from 0 and having 10 numbers in there. You can do the same thing with NumPy as well. And so let's call this like array 3. I'm bad at names today. I need more creative names. Let's do, so there's a function called arange. It's basically the same thing as NumPy as range in Python. So yeah, as you guys can see here, it's basically the same as a range function, but it's a NumPy array, which is more useful in general. We'll get to see why. But basically the parameters are a start number, a stop number, and a step. And so I didn't actually talk about step in the last case. We'll see what it is in a second. But start is like where we want to start. And so the start is inclusive. So if you put 0 in there, it'll have 0 in the value. Stop is going to be an exclusive value. So it's going to go up to this value. So exclusive. And step is how much like difference we have between consecutive elements. So like if step is 2, that means that every time we go from one object or one element or index to the next, we're going to add 2 instead of typical 1. And so to see this in action, let's do like a typical range from like 0 to 10. And so, let me print it out. 3. So yeah, we get the same thing, right? And so that's awesome. But we can do more things like that than that. So I missed this person. Array 3 we have, for example, we could make that even better. But like, let's say you want to do something cooler, like arange. So let's go from 5 to like 15 and go by like 3s, for example. And let's see what that is now. So you guys can see we start at 5, we add 3 every time instead now, and we like make sure we don't include 15. So 14 is below 15, and if you go 3 more, we get to 17. And that's not in our that's above our breaking point, so we stop there. And so NumPy.a range is pretty flexible. You can make like, let's say we want to make like a really big one, like 1,000 or something. We could do a really big array. Well, that's huge, but yeah, the point stands that you can do this for like, and this like this gives you more flexibility with your array creation. Similarly, you might want to, instead of specifying your start point to end point, you might want to specify instead like a certain number of data points and a space between them instead. And so this is where numpy.linspace comes in handy. So you type in numpy.linspace. And so this is similar to a range in that the syntax is pretty similar, but the main difference is that it's evenly spaced numbers, and also you can set the number of data points. So let's say so start, end, and also number of data points. And so it's because so basically we can go like, let's say you want to go from like 5 to that's the same one. Let's go from 1 to 42 by 0.5 or something, and print out array 4. Oh, it should be non-negative. Whoops. What was the order again? Oops. Technical difficulties. You love to see it. Actually, you don't hate to see it, but see it again. Start, stop, number. Yeah. So yeah, so let's do 142, and let's go like 50 or something. So now you can see that like these data points, even though they look pretty messy and like you never would figure them out by hand, they are actually evenly spaced between each other. And so like looks like they're all like 0.83 something between each other. And so that would be 41 divided by 50 or something like that. About that would be a difference. And so this allows for a different amount of flexibility in your arrays. Other things. So let's say you want to make an array of a certain size. So let's say you want to make like a 5x6 matrix and you don't really know the values of it yet, or you just want to initialize it. You can do numpy array 5 equals numpy.zeros of like 5,6. Oops. And so what this does is it just creates arrays of all zeros at that value. And so this is a 5x6. We can also do like, if you didn't want 5x6, we can go like 10. That works too. So anything works there. And similarly, we have numpy.ones. If you didn't guess, you guys probably guess what this is, but pretty self-explanatory. Same business. It's just like 1 instead. And so this is the reason why you want zeros or ones, because zeros and ones are pretty usually pretty usually used to instantiate arrays and stuff. So if you want to like zero out array or have a zeroed out array to start with, or like all ones arrays, like for example, like all 1 probabilities, for example, start with or something. These are the ways to do it. And if you don't care what your array looks like, you can do array 7 equals numpy.empty like 5,6. Oh man, okay. And you guys, as you all can see, oh, that's actually quite nice. Usually it's not this nice. I'm surprised it's this nice. Usually it's not this nice either. I'm surprised, but usually it's just this okay, yeah. As you guys see, the behavior is pretty random with this, and there's a reason for this, that this command is actually the quickest of all these other commands. So it's quicker than 1, quicker than 0, quicker than 1 space, quicker than a range, because it just creates the space and gives you the array, but doesn't actually set the values to anything. And so even though it's all zeros in this case, it could directly be anything. And so if you call numpy.empty, you shouldn't afterwards be trying to access values, because or like trying to like read value, because they're all gonna be kind of randomized. And so it's unpredictable, but you can always use this to like have the structure ready and then start filling in values. It's like, yeah. And we'll get into how to fill in values in a second, like access and like read values from array, but that's very soon. And also, so those are the main ways to think of things, but there are some cool things with like randomness as well. And so if you want to create like a random number, for example, NumPy, like there is random in Python, but NumPy has its own random stuff. So NumPy, can I spell random? All right, random. Awesome. And so say range between 1 and 50. 150. Oops, my bad. But the same thing is that basically this will give you a random integer between 1 and 150. If you want more numbers, you can do out of 5 there, you get an array instead. I'm pretty sure, let's look at this. Let's actually confirm the syntax of this first, but high, low, size. Yeah, okay. So we said a 5 before, so it's the 150. We can actually input like a size like 6,5, and that should be an array. And so we have more flexibility to create like a random array of a certain size. And so this allows for randomness basically. And so we've seen a couple of instances already of how randomness is pretty helpful sometimes in machine learning. And so this could be a way to do that as well. And there's other functions too, like numpy.random.rand. This is no longer actually an integer. It actually just returns a random number between 0 and 1. And so we just did this. We random number, typed in 10, be 10 of the random numbers. And if you typed in like 100 by 100, it'd be a lot of it. Oh, never mind. Look at the syntax. Let's look at the look at the docs real quick. Oh, so this one is pretty tricky actually. So I'm pretty sure if I typed in 10, 15, this would have worked. And so NumPy is pretty tricky sometimes. Usually it is this form. So this is called a tuple. I don't know if we went over it yet, but tuples are basically like a set of elements in like parentheses. It's like kind of like a group of things together. And so in this case, the inputs aren't actually a tuple, but just like a set of like a list of like just parameters in a row, basically. So like no more parameters. So this is a bit tricky in that way, but it is what it is. So that is it. All right, that was a lot of stuff. This is like, these are the most common ways you're going to make a NumPy array. And so that was great. And so any questions about creating NumPy arrays? Oh, got some barking. Dog is mad. It was bad. I don't know. Probably a post office person or something. Actually, just gonna wait for that. I don't know. Any questions though? Yeah, I'm guessing my dog is a question probably. It's probably the most likely explanation. But I can answer that later because he's at home. So I can always talk to him. So cool. Let's move on. Because that makes sense to everyone. And so let's go into indexing and accessing elements. And so now that we have our NumPy arrays, we want to like actually like look at the values inside of them and like do stuff with them. And so the way we do that is by like accessing like the certain index. And so if you remember with lists, actually let's call this X. And so, oh, I need to print X again. Yeah, so X is a pretty simple array. It's a 1 by 15 array. So it's technically 2 dimensions, even though it's like 1 by 15 because the way we inputted it. But that was the case. Indexing into NumPy arrays is pretty similar to indexing into lists in general. And so the way you want to get certain values is you have an x.0. This is actually a special case because if you notice that our arrays are 1 by 15, by indexing into the 0th element, you actually index into the first layer. And so that's just a quick niche thing, but let's just get rid of this for now. And we'll see that this 0th element of this 15 element array is 0.06, as you expect. 10th element is this value right here, 0.83. And so the same applies to higher dimensional things as well. And so let's create like a NumPy, like a test array called numpy.random.randint 150, and let's make it like a 4x7 array. That sounds weird. Or so make it a 4x7x2 array to be fancy. Oh, I need to print it out. This 7's pretty large. Let's do 4x3. So as you guys can see, yeah, 4x3x2 array right here. So kind of complex, but we can index it into it the exact same. And so if we do test array of 0, actually I'll ask you guys, what do you guys think will happen if we input when we input test array of 0? What will the output, like which of these, or like what numbers will appear? Do you guys think? Or which number or numbers? The whole top block? All right. I think you're onto something. Let's go ahead and try it out. But yeah, you are right in that the way you look into an array is that, like, yeah, it's just like, imagine that these blocks are like, just like in a 1x1, like imagine this test array as being like test array equals like 4 X blocks, and each of the X blocks is like one of these things. And so because the first dimension is 4, like Maxwell said, the whole first block will come up. So test the array of 0 is the first X, and the first X is like the first section. So yeah, exactly. And if we add on to that, let's say we add on 2. Now what will we get? (69, 140). Yeah, I agree. So the way we got there, the way you got there was that test array of 0 is this first top block. So that's this part. And then you can think of this as like, this is a test array 0, 0, 0, 1, or 0, 1, and then this would be 0, 2. And so that is that. And then finally, if we go into 0 element of that, or let's do 1, that's fancy. What do we get in this case? Hopefully everyone can have an answer for this one. Yeah, 140 should be that. Yeah, because first block is 0, and then third block or index 2 is 69,140, and then the second out. Remember that index by 1, we're 0 indexing, so this is the 0th element and this is the first element. So yeah, awesome. And so in this way, we can actually access different parts of the array. So like if you want like, so this is a three-dimensional array. If you index once, you get a 2-dimensional array. Index twice, you get one-dimensional, etc. I'm pretty sure you can also go like this as well. So I'm pretty sure this should have worked as well. So yeah, same thing as well. So you don't actually need the separate brackets, but nonetheless, both ways work. this only works for Numpy arrays though, so it does not work for typical lists and stuff. So keep that in mind when you're working with that. That's awesome. And so there's actually more to that actually, but let's actually dive into exactly more. So let's say you're not happy with just being able to ask, like, so we did test arrays 0, 2, right? And that got us these two values. Let's say you wanted to get all of these second second column values, for example, right? Or like in the inner arrays, you want to get all second values, right? And so in using this context, it's really hard to do that because it'd be like 0, 0, 1, 0, 0, or 0, 1, 1, 2, 1, and then 1, yeah, onwards. So like it's kind of hard to do that with our typical syntax. So the way we actually do that is something called slicing. And so slicing is pretty helpful to get like certain parts of arrays that you can't access with typical indexing. And so it comes in pretty helpful for like separating training and testing data in particular, but also separating data in general if it's all combined. And so in this case, let's say we only wanted to get these third column values. What we do is that, so we don't care about, okay, first let's dive into splicing, but we'll get into this. But let's say first we only want the third values of these two top blocks. So the way we do that is actually, so this is called a splice operator, or one of the operators. It's used for splicing. And so the way it works is that up here, these values will tell you which like indexes to check out, and it'll give you one index. But with this operator, with this colon, we can actually tell the array to look at multiple indexes at the same time. And so if we do, like, for example, 0, 2, what we'll end up getting here is like we start at 0, so 0 is inclusive, and we go up to 2, but we don't include 2. So what this does is actually it ends up including the first one and the second one. So it's index 0 and index 1. And so with slicing, we can actually force our code to, instead of only accessing one index, we can access several indexes at the same time. And so let's say we wanted to like be even more particular with our code. And so we did like, well, this one only has 3 possibilities. So we got a little bit more limited, but let's say we did 1, 2. So now we only have our second columns of everything. And then let's say after that, we want to only get this second column of these. We could do, well, there's no point to actually do like 1, 2, because that's just 1, but this should work. Okay, you can also just do 1 in this case because it's the same thing. Because if you guys just checked it out, 1, 2 is just the same thing as only doing 1. And so, or it's almost the same thing as doing 1. Yeah, in general, I think, yeah. So because we start at 1 and we don't include 2. So yeah. But going back to our original task, or actually before we did that, this operator is actually pretty versatile. So we have our left side and our right side here, but we don't actually need both of the sides. And so let's see what happens if we actually exclude this side. So if we get rid of the 2 that was limiting it, this 2 basically goes away. We actually end up including the rest of the array. So let's say, so now we go from 0 all the way to 5. And so this basically says that we're going to start at this point and go on till the end of the array. And so this ends up being the whole array because 0 is a starting point of any array. So if we do like 1 instead, we start at this block and then we go on everywhere else. And the same applies vice versa as well. Yeah. So we did 0, from 0 to 2. That does 0 to 2. And so back to our original question, if we only wanted to get the second column of everything, what we can do is actually exclude the stuff on both sides for the first 2 and type in 1. And so as you guys can see, what this does is basically it looks at all of the x and the first two dimensions, and it only picks the second element of the third dimension. And so we got 127, 37, 140, and you can see these all apply as well. So any questions about splicing? Because this is pretty helpful in general. And if it's a little bit confusing, play around with it a little bit more. But the main concept is that it lets you look at multiple indexes at the same time, like a certain slice of index or a certain slice of the array at the same time. So yeah. All right, let's go on to next. If no one has any questions, we'll move on to a couple attributes real quick, and then we'll finish up with some functions. So a couple attributes some of these arrays have. So one is called shape, and so if you type in shape, we actually end up getting a tuple in response, which returns like the size of like every single dimension of the array. So that's pretty helpful. You can type in shape of like 0, that returns 4. So that is just pretty helpful in general in case you want to figure out how big your array is. We have test.enddim. Oh, test array. And that returns the number of dimensions we have. So this isn't as helpful as shape, but it can be used at times. You have another kind of helpful function depending on your use case is size. The size is just the product of all your dimensions, so number of elements you have. And you have a fourth thing, which is pretty niche but helpful for debugging, is dtype. And so this will tell you the type of all your inputs. And so if you ever have errors with typing, this can help you figure out which arrays has the wrong types. And so it might not be useful right now, but it'll be useful for debugging in the future. Any questions about attributes? I think this is probably the easiest section of all the sections so far. So hopefully that makes sense to everyone. Yeah, cool. All right, two main things left are reshaping and functions. So let's go into reshaping right now, because I think this is a pretty important topic. But so we have our NumPy array. We have our test array called test array. And so it's currently a 4x3x2 array. But let's say you wanted to change that. We want to make it like that's 24. So let's make it a 6x4 array instead. So we can do something called reshape. This is actually change the dimensions of the array. And so we can reshape. We end up getting the same elements of this array, but reshaped to be in a 6x4 case. And so this is pretty useful in general if you want to change your dimensions of your array. We used it for one of the projects earlier, or for one of the coding sections earlier, to change dimensions, and that's pretty useful. And so yeah, really useful in general. Make sure that your dimensions multiply to be equal to size, or else it won't work. Cool. One more thing I want to talk about, reshaping. Oh, one more thing before I click. Numpy arrays are pretty useful for just general functions in general. So I think if we typed in this is not on the same topic, but it's very useful, is that 50. Oops. It's not X, right? It's just the array. Test array. This will get us all elements greater than 50. So in case you want to scope out certain elements that are useful, this could be helpful. This is kind of niche, but it's still really helpful in general. I thought I'd throw that in there. Yeah, let's dive into functions right now, and we can go on to pandas in a second. So NumPy is pretty nice. It has a couple of nice functions that apply to the entirety of the array. And so the way this might work is that we have functions like numpy.exp, which if you apply test array to, it just takes everything to the e to the power of that element. So basically it goes element by element and applies a certain function to it. There's things like numpy.sign, numpy, or I think you can do test array max. So it works well. So it's the highest value. Numpy.mean test array 0.5. Other functions like this, for example, that are pretty useful as well. But Numpy has a lot of cool functions that you can apply to your matrix immediately, element by element, and it's recommended that you use their functions if they have one, mostly because their functions are actually optimized to run pretty fast in your matrices. So compared to like your own functions, it's probably going to be running a little bit faster. Yeah. One other thing is that this mean function has a variable called axis, and so axis is pretty important for like making sure that you're calculating things over the correct like dimension. And so I think the default is 0, and the default is none of the flattened array. And so let's say we did 1 instead. So what this does instead is that forward parts. So what this did here is it actually calculated the average over these columns, I'm pretty sure. So calculate the average here, 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 and got us these values. And so by changing the axis, you can change over which like dimension your calculations are over. And so that changes the output as well. And so same thing applies with dimension axis 0 and axis 2 and stuff like that. But it's pretty useful to know which dimension your functions are being applied over. So that's the main point of axis. And if you don't have access at all, it'll just make this into a one-dimensional array and find the and apply the function to it. So that's why this is just an average of all the numbers in the list right there. All right, so those are some functions. And so with that, how much time do we have? Okay, so let's quickly remind ourselves about like a cool function we talked about last week called softmax. And so if y'all remember last week, when softmax basically took in an array. So here, let me make a codes, a hex cell. So softmax. So softmax, what it did basically is that it took in input equals an array. And so what it did is that it took e to the power of every element in the array. So e to the power of each element in array or in vector. And then for each element, or it divided it by, or here, let's read this thing. So for each element in the array, or in the list, in the vector, its new value would actually end up being e to the power of that thing divided by sum of e to the power of all elements in the vector. Let's see if I can get the image from before, but I don't think I can right now. But hopefully this makes sense to everyone. But if not, don't worry too much. But main purpose is that we can implement this in Python, but actually using NumPy makes this a lot easier. And so what we're going to do real quick is we're actually going to implement this softmax function in using NumPy. And so some functions that you should probably keep in mind are numpy.exp for exponent, numpy.sum. And so with that, I'll give you all some time to think about how you would implement these functions with that. But hopefully this part makes sense to you all. I'll try to get the image up in a second, but just take a minute or two and try to figure out, or a couple minutes maybe, to figure out how you might use some function to take an input and make the output be the softmax value of it. And if you have any questions, feel free to ask them as well. Because this could be a little bit complicated, but it should be not too bad. And if you have code ready, feel free to type it in chat, or if you have like one line or two ready, type that in chat too. Because yeah, or questions as well. All right, it's been like a minute or two. Don't want to rush everyone, but anyone have any ideas on what they might want to do to, or what we might want to do in general to figure out or to code this function? I'll get us started with two things, which are you're gonna want the sum of all like the total sum. So like total is like numpy.sum of like numpy.exp of input, and the exponent part is like so like exponent equals numpy.exp. Hopefully that helps. Yeah. Oh, max out some code. Let's see. For I in input, I equals numpy.exp over numpy I. Yeah, I think that would work. I think that would work for sure. You can try it out. Let's try it out actually. I think it might not get modified correctly. So this might work, it might not work. Have my couple of doubts on it, but we'll see. Or if it's or some studio array. Yeah, I can do that too. This will be pretty quick for our example, so let's just do this for now. I might have forgotten to tell you guys something about Numpy arrays in general, but we'll see if I forgot that's it. Yeah. So one thing I forgot to tell you guys is that Numpy arrays are kind of weird with self-modification. And so something called mutability, in that Numpy arrays, when you apply operations to them, it's possible, but it's like typically not recommended to change the element itself while like doing the loop itself. And so that's one of the reasons why this is a little bit challenging, is that while this code makes sense and like it will work with like a list for sure, the problem is that NumPy arrays are a bit annoying with changing stuff. Improvise, you can probably yeah, okay. Let's actually implement instance change, because that might change things. Not, oh, what? Whoa, that's interesting. They aren't normalized for some reason, but it is different now. So things have changed. I'm guessing there's some rounding or something going on. Let's think. So implemented one, e to the first.
Okay, I think I know what the issue is.
All right, see it.
Because like you're modifying the array as you're looping through it.
Oh.
So that's why
Yeah,
if you're working with NumPy arrays, I do not recommend like using for loops for this particular reason. You can also easily create a new array and just modify the new array. I think that would work.
I think this should work as well, but let's see if this doesn't work. No? Guess it didn't work. Interesting. I thought this would work for sure. Never mind. But yeah, I was guessing that moving the sum outside, just because now the sum is constant, would change things, but I guess not. But yeah, in general, not advised to like loop through arrays unless you're loop through NumPy arrays unless you're just accessing values. And so I guess we can dive into that real quickly, but there actually is a function for looping through in a NumPy array, which is called for, like, you just do for index comma element, or just do e in numpy.nd numerate, and then we type in input. And so that would iterate through things. And then typically this function is used just to read values and access values. And so it's typically a little bit harder to modify values in a loop, because like things like that happen, like Vincent's talking about. Like if you modify the loop and then calculate the sum again, it'll change the sum, or but so yeah, typically kind of try to avoid that stuff. But definitely a good suggestion though. That it makes sense. It's NumPy is a little bit weird. It's the main, like, that makes perfect sense in Python. So it's just NumPy is a little bit weird. Since we're a little bit not low on time, but like we like getting close to 8 o'clock, I'll just type out a solution that should work. Is that, like, let's say we have s equals numpy sum of numpy.exp input, and so that's just the exponent. That's this part right here, the sum of each of all the things in the vector. And so remember that because exp is actually a vectorized function, so this is a numpy function basically, you can apply it to the entire array at the same time. So that's really useful, because now we don't have the for loop anymore. We can actually just apply it to the array at the same time. And so that's really clutch right there. And so now we have that, we can type in like e equals numpy.exp and then we can do like ret equals e over s. And so s should be a scalar now. S should be the sum of all values. E should be still a vector. E is actually a vector of all of input, all raised to the e power, and sum is actually the sum of all those things. And so this is a scalar. And so vector divided by scalar just divides each element scalar by scalar. And so now if we return ret, this should work. I think that adds up to 1. We can actually sum that in numpy.sum and see if that works. Or say y. Yeah, so as you guys can see, our softmax works now. And no, now we can't print it out anymore. But yeah, softmax works now. And so having these vectorized, or having these functions that apply to the entire NumPy arrays are really useful, because it makes like things like softmax a lot very easy and simple to create for a programmer, because you don't have to loop through the entire array or vector or matrix. And so you can imagine that if like your if this is actually a matrix instead of a vector, and if it was like a 10-dimensional matrix, you don't want to index by, you don't want to like for loop through every single dimension, right? Because it's a little bit complicated and like prone to error. And so these functions are really useful for just like applying to the entire matrix. And so hopefully this example kind of shows you guys these functions, as well as how they're pretty useful for machine learning, because softmax is pretty important in general. So now we know how to actually implement it in code. So that's pretty awesome. Yeah, that could definitely be changed. So yeah, you're totally right, Dylan. Yeah, I could definitely do E and then E and type in E right here. Definitely more efficient. Actually, like definitely a valid point to bring up if you're really focused on improving speed, because Python itself isn't the fastest. So if you want to speed up your program, some like depending on the size of your matrix, this change could change like a good amount of things. So, yeah. But yeah, in this case of a 4-dimensional or like a 1x4 vector, it won't make a difference. But if this was like 1,000 by 1,000 by 1,000 by 1,000 array, then maybe it make a difference in like speed. But yeah, we'll see. But yeah, any questions about NumPy in general, or else we'll move on to Pandas with Jensen. Pandas with Jensen sounds like a zoo exhibit or something. All right, there's no questions. Yeah, I'll post this link on the slides later on, so you guys can look at this later. But yeah, this is like a good amount of the important stuff about NumPy. So now that you notice, you should be ready to just like play around with NumPy a bit more, as well as use it maybe some in our future projects, which start next week, or our guided project, which starts next week. So yeah, with that, I'll let Jensen take over for Pandas.
All right. Let me share screen. So hopefully everyone can see my screen. Okay, so first let's import pandas as PD if you haven't done already. So pandas is another like data science library that is like pretty popular nowadays. So it's not as commonplace. It's not as commonplace as NumPy, but it's also like pretty useful for like data analysis and stuff like that. So hopefully you guys have import pandas. So let's create a pandas series. So a pandas series is pretty similar to a NumPy array in a lot of ways. So the only difference is you can specify like the index, which is also an array-like or index object. So let me show you how to initialize a pandas series. So just like a NumPy array, you would specify the values. But then there's this additional argument that allows you to specify the index. Just bear with me for a second. All right. So now let's print out some series. So yeah, now our index is A, B, C, D, E. And our values are 1 to 5. So I guess in this way, like a pandas series is a little bit more flexible compared to a NumPy array. So the interesting thing is you can also like create a NumPy array with a pandas series, like so. So sometimes like function like only takes in a NumPy array, so you have to cast a pandas series to a NumPy array. So let me print out the type of some series just to make sure it's a pandas series. Yep, so it's of type panda.core.series. This is kind of like a little redundant, but I guess this is just what it is. So like a NumPy array, you can use the index to access a particular value. So in this case, our index are, remember from A to, oh, I just realized this is C. Whoops. All right, that should work. So some series sub A should return 1. And you can also perform like element-wise like operations on Panda series, just like for Numpy arrays. So let me create another series. Okay, let me just copy this just to save me some from typing too much. So let me change the values. And then let me add them together. So this is our element-wise operation that we're performing. So as you can see, this basically just adds all the data from some series to another series. Okay, so what would happen if the index doesn't line up like as you expect? So if I switch them, then you can see like the summation of this is also like adjusted, because now like A has 20, but it's defined like as the second element, and A up here is 1, so we get like 21. So I guess order doesn't necessarily matter too much as long as the index line up. So this might be a little bit quirky at first, but I guess I can also show you like what if the index don't line up perfectly. So now for the, so because like an uppercase A is not equal to a lowercase a, so it turns out like in the sum, both of these are nans. So this is something that you keep in mind, because you generally don't want to, you generally want to like avoid nans. So nan stands for not a number, and this is something that you don't want to feed into your machine learning model. So yeah, this is just something that you should keep in mind. So always make sure that your index line up like the way it should, or else you're gonna get into a little bit of trouble. All right, so so I guess a Panda series is pretty neat on its own, but it's not too useful. So let's, I guess, create a Pandas data frame. And let's create, I guess, a Numpy array just to, as the data of the Pandas data frame. So I think you guys might have defined this earlier, but I'm just gonna do it again. So numpy underscore array is just like basically a random integer, or an array of random integer with like 100 elements, but then I'm reshaping it to 10 by 10. Okay, so this is what the array looks like. And now we're ready to create our Pandas data frame. So a Pandas data frame is kind of like a Pandas series, but it has like 2 dimensions or multiple dimensions. So let me show you how to. So to initialize a data frame, it's basically very similar to a series where you pass in like the data, which can be like a Numpy array, a dictionary, or another data frame. And the index is also like an array-like thing, and same thing for the columns. So let me give you an example on this. So I can pass in Numpy array as the data, and then for index, I have to create a list. Hold on, let me wait. Oh, whoops. Give me 1 second. I guess I have to add more elements as well, because there are 10 elements. And then I guess for the columns, I will I'll do like a lowercase version of the for the index of the columns. Okay, let's see what this looks like. Oh, is it column? Oh, I forgot comma. Whoops. Okay, so yeah, this is what our data frame looks like. So it's pretty much like a Panda series, but has like 2 dimensions. So to get like a column, you can like specify the label of the column. So just like how you would do it for a Panda series. So if I do df sub a, I will get this whole column, or it's kind of hard to highlight. So 11, 97, 20. So this is like a Panda series. So yeah, so all the functions, all the methods that we talked about earlier like applies, because yeah, there's like another Panda series. And you can also like check the data type if you're interested. So it's pretty useful for debugging. So it's in 64. So I think Nikhil show how to do this for a Numpy array as well. Let's see, there's something in chat. Does the data frame has to be 2-dimensional? Actually, I think so. Right, I mean, you can have like 1 dimension, but then you also have to specify the column, I think. I guess you can test it out yourself, but I'm pretty sure it has to be 2 dimensions. It can, the second dimension obviously can only have like 1 element. So in that sense, it's kind of like a 1-dimension thing, but I think technically it has to be 2 dimensions. Okay, so how do you get like a row instead of column? Because if you do like df sub capital A, this is obviously not gonna work, unfortunately. So to get a row in this data frame, you have to use the lock method of the quick dot. So yes, you can see the lock method accesses a group of rows and columns by the label. I can do, oh, no access named A. Interesting. Oh wait, I have the wrong stuff. All right, this should work. Okay, so this basically gives you the first row, or the row that corresponds to capital A. So this is another Panda series. So this is how you would access like rows and columns in the data frame. So this is pretty useful. And I guess you can also like append like and remove rows and columns in the Pandas data frame. So if I want to add a row or a column, I should say. So the way you add a column is just to specify like a new element. So I'm appending a column after J, and then this column is going to be a Panda series, as I showed earlier. So data, I guess I'll just create a Numpy array like randomly. I think we need 10 elements, right? And then, okay, I think I need to take the index up here. All right, so this basically adds a column after J, which is exactly what I said earlier. So to add a row, you have to do something, I guess, a little bit different and more verbose. Because like, as I showed earlier, you can't just access a column by using this syntax where you just specify like I guess the name of the row, which kind of sucks to be honest, but it is what it is. So if I want to add a row after or below J, then I have to, okay, so let me store this Panda series in another variable. So I guess it's random, right? So now I need 11 elements instead of 10 because I added this new row or column. And let me copy this again. Or actually, no, it has to be lowercase. So this is going to be our index. And then I also have to specify like the name of this Panda series, because that's going to be the name of our new row. Oh, forgot to add an extra entry. And then to append the new row, you can do df equals df dot append new row. So this is kind of self-explanatory. Appends just like appends a new row to the caller. Now our data frame has like an extra row down here. So yeah, any questions about Pandas data frame? Or I guess like adding rows and columns. See how we're doing on time. I think we're doing okay on time. So I guess another useful thing to know is you can drop a column or a row. So this is useful if you have like a bunch of like I guess bogus values in your data frame for some reason, then you can always drop it. So okay, I was just messing around. So in order to drop like a row or a column, you have to use the drop method. So let's pull out the quick docs. So drop basically just drops specified labels from rows or columns. So yeah, it basically just removes that row or column that you specified. And I guess a pretty important thing to know is you have to like also specify the axis. So we're gonna, I guess, so axis can be 0 or 1. So 0 is for rows and 1 is for column, and it defaults to 0. So this is gonna come into play like a little bit later. So yeah, let's do like an example. Let's just drop the last, I guess, row. So this is the one that we just added right here. And I guess I didn't specify what in place is, but in place basically just allows you to, I guess I need quick docs. So in place basically just lets you drop a column without having to, like, I guess reassign it to the same variable. So this is the same as like df equals df dot drop z. So if you set in place to true, then this saves you from typing this, which is pretty neat. So now we have dropped our last row. And let's say we want to drop the last column as well. So you can do df.drop lowercase z in place equals true again. So what's going to happen here? Any ideas? if this is gonna work, or if it fails, like why. Okay, so it turns out this doesn't work. And the reason is because the default access is 0. So Python is going to be looking at each of these columns and trying to like see whether anyone's like equal to, or at all of these rows. I think I said column for some reason. I don't know why, but it's going to look at all of these rows and see like if any of these are equal to z, lowercase z. The answer is no. But what we're really doing here is we want to drop a column. So I have to specify access equals 1. So this should work. All right. So another cool thing that you could do for a pandas data frame is you can select elements conditionally. So I think Nikhil kind of showed how to do this with a Numpy array. So you do df greater than 50, then you get like a data frame of Boolean values. So that's pretty cool. So the cool thing is you can pass this back into the data frame itself as like as the argument. So this is going to give you like all the values that are greater than 50, and then it replaces the other values with nans. So usually nan is not good, right? Because it's not going to work like the way they want to when you fit into your model. So in general, you want to like get rid of these nans. So one way to do this with the fill NA method. Let's see if I can pull up the docs, or is it not going to work? It's unfortunate. Okay, I think Colab sometimes like glitches where it doesn't give you the quick docs. So you can, so I guess like something that you can do is just fill all the nans with like 0 or some arbitrary value. Wait. That's weird. Okay, so this works. So if I want to like replace all the nans with something else, so like for example this sad face, then you can use the fill NA method. So I don't know what was going on earlier. That was kind of weird. All right, so let's, I guess, move on to like the data analysis part of the workshop. So as I mentioned earlier, Pandas is very useful for doing like some, I guess, basic like data analysis. So I think we've prepared like a couple of CSV files for demonstration. So I've put the links here. Let me post in chat. All right, I think the link should work. Let me try. Okay, yeah, so this is our CSV file. So I guess this might be from like a Excel spreadsheet or something, but yeah, so one reason like Pandas is like a very popular library for data science is it has this built-in method called pandas.readCSV. So readCSV basically just reads in like a CSV file, and then it converts it to a data frame. So this is pretty neat. So let's see, let's try to do it here. Oh. Okay, there we go. So now our students is like a data frame of 1,000 rows and 8 columns. So this is like basically, I guess, a nicer representation of the CSV file here. So that's pretty neat. So something that you can do in Pandas is, if your data frame is really big, you can like use head to specify like the first 5 rows, and you can use tail to get like the last 5 rows. So this is something that you can do. It's pretty neat. And I guess like if you do students.info, it'll give you like a nice little summary of the data in the data frame. So yeah, so with so using the methods that we learned earlier, you can actually do some pretty cool stuff with this data. So for example, if I'm interested in like how many students here are male, so our data set has this attribute or column called gender. So if I want to figure out like how many of them are male, so one way to do, or to start off, we should get like the column. So this is the column that corresponds to gender. So this is a data frame, or this is a Panda series. And then I want to see like which of these are actually male. So if I do, if I equate this to male, so you would get like a Panda series with a bunch of like Boolean values. And then if you call sum on this, you'll get like a number of all the male students. So let me type out the question. So this is how many male students that's in our data set. So if you're interested in like the average map score, for example, because I think there's like some kind of like test data set or a data set on like test preparation. It's probably on the SAT, but don't quote me on that. So average map score. So another method that is useful is, actually I'll just get the column first. So yeah, this is the column that we're interested in. So a useful method here is the count method, which gives you like how many elements is in this Panda series. Another useful method is the sum method, which basically sums up all the entries in this call or in this data frame or Panda series. So if you divide the sum by the count, of course I didn't do that correctly. And this is your average map score, right? Because you divide the sum by the number of entries and you get the average. So another cool thing that you can do is you can actually group the students here by their ethnicity. So let's see. Oh wait, let's actually figure out like how many like unique ethnicity we have. The number of unique ethnicity. So let's get the column that is useful. So it's race / ethnicity. So you can get like, you can call the unique method. So this would return like all the, I guess, unique values that are in this column. So this is actually a Numpy array. And I guess something that you can do is you can group them by their ethnicity. So you can call the group by method. So let's see. A group by operation involves some combination of splitting the object. So yeah, this is basically just like, so let's see what this does. So it basically just splits the data frame using that ethnicity. So I think this is how you do it. And then, yeah, I should just run this first. Dot head. So yeah, let me store this into a variable so we can use later. All right, cool. And then if we want, we can actually like compute some statistics. So if I call students by race.mean, I get like an average of all the, I guess, all their scores by their race. So this only has 3 columns. So you guys have any ideas like why this only has like 3 columns as opposed to like however many we have up here? Let's see. The other values aren't numbers, yes. So it doesn't make sense to take like, I guess, the mean of like the lunch. So if you add a standard lunch with like a free or reduced lunch, that doesn't really make any sense. So this only computes the mean for all the numerical columns, if that makes sense. So I guess another useful thing that you can do is you can, I guess, so you can actually figure out like how many people have like standard lunch by using value counts. So this basically gives you like for each of these ethnicity groups, how many people have standard lunch and how many people have free lunch. So value counts is a pretty useful method. So let's put the quick docs. So it's not working again. Okay. I think the quick doc is kind of shaky sometimes. I don't know why. So this is, let's see, how many ethnicity group. Standard lunch or free lunch. I guess something else that you can do is, oh, that works. So another thing that you can do if you want to like figure out like what is the, I guess, the maximum value of a column is by using the max or the min method, as Nikhil pointed out like earlier. So I can do students sub reading score on max. So this would give me the max reading score. So I can similarly do like the get the mean of a score. So let's do writing score. It's to mean, or yeah. So this would give me the minimum writing score. All right. So that's pretty neat. So any questions about what we just did? So hopefully it's clear like how you could use the methods that I defined earlier for Pandas series and Pandas data frame to actually do some like answer some pretty interesting questions about like a data set. Okay, so I guess like if you guys don't have any questions, we can move on to another data set. So let me put the link. into chat. Okay, so I guess I can just load this in the same way. Okay, and copy correctly. Let's call it something else. As I can call this salaries. All right, so this would give me like another data set. And this data frame is pretty huge. It has like, so this is a pretty big company. It has like 140,000 employees. So I guess this just goes to show you like how powerful pandas can be when you're working with like big data sets. So let's first pull up like a brief summary. So I can do salary info. So this gives you like a pretty neat little statistics about like all the variables or all the columns, which are the features. And then, so as you can see, like this data set is kind of like not the best because it has like these like NaN values and also like not provided. So let's do some like pretty basic data cleaning here. So let's see. So let's check out all the unique values of the column. So let's say benefits. I think we can do unique. So yeah, these are all the different values that are in the benefits column. And then we can check out another column. So let's see what's a good column to check out. I guess we can check out notes because it looks like it has a lot of NaNs. Okay, so it looks like the only thing that's in this column are NaNs. So this is a pretty useless column because it doesn't have any kind of information at all. So we can drop this. So if we specify the axis again, because it's a column. So remember, you have to specify the axis because it defaults to 0. And I think the last thing is just setting in place to be true. Let's look at the head. All right, so this column is dropped. Yeah, so notes is behind column or years in our original data frame. So now this is removed. And I guess an interesting question is to figure out like who's the highest paid in this company. I actually want you guys to try like figure this out on your own. So I'm gonna give you like maybe a couple of minutes to think about this, and then we can go through it together. you guys have any questions about like, I guess, Pandas data frame in general, you can also ask them now. Because I think Pandas can be kind of confusing if this is your first time, but I think the methods are pretty powerful. All right, so I guess first we have to figure out who is the highest pay. We have to like first figure out like which of these columns are actually like the relevant one. So I think total pay and total pay benefits are kind of similar. So I'm just gonna pick one of them and try to like go from there. Let me get, okay, highest paid equals, so I want this column, right? So salaries, total benefits. Okay, so what do I do next? So let's, actually I don't need this variable yet. So I guess let's figure out like what's the highest salary first. So the highest salary is about like 560,000. Okay, so now that we have the highest salary, so how do we figure out like who has the highest salary? So the answer is you can actually set this equal to, or equate this to, I guess the column itself. So what you get is you get like a Pandas data frame of like Boolean values. So I think we got lucky that the first person here actually has like the highest paid or the highest salary. So we could just figure this out from this data frame up here, but let's pretend this doesn't exist. So this is where I guess my variable would come, oh, whoops. So let's store this into a variable. And then I can pass this Panda series, because I think highest pay is the Panda series now. So I can pass this back into the data frame, which is, I guess, what we did earlier. I think we actually did something similar earlier, but yeah, so this is going to give you the row that has the highest salary. And then if you want to print out, I guess, the name, you can do like employee name. All right, so this would give you who has the highest, who is the highest paid in this company. And I guess like a related question would be like, what are the 5 most common like job titles? And to do that, you can do something similar. So let's first get the columns. So let's see. Let's get job title. So this is our Panda series here. And then to get like the 5 most common job titles, we can do value counts. And this is going to give us like, I guess, the count of all the values or all the possible values. And then to get the first 5 elements, you can do like a slicing. So this works exactly the same way as a Numpy array. So I think Nikhil like briefly mentioned this earlier. So if you do like 0 to 5, you get the first 5 elements. You can also drop the 0. So this just, so if you drop the first index, it just starts from the beginning and then goes up to, but not including like the 5th element, or I guess the element that's indexed 5. So this would give you the first 5 elements. Okay. So that's basically all I want to cover about pandas. Hopefully the examples are at least kind of interesting. So I guess I would encourage you guys to like do the worksheet, because like I think I covered we covered all the concepts pretty quickly. So in order to really like, I guess, drive them home, you kind of have to do some more practice in order to actually like master Numpy and Pandas. So I would encourage you to work on this. I think we still have a little bit of time. So Nikhil, do you want to work on this right now, or let them do it like, I guess, after the workshop?
I don't know. What does everyone think? I mean, it's almost time, but we have like 20 minutes if people are interested. I guess like just write in chat if you would want to work on it now or want to work on it later. Either way works for us.
I guess this is technically like the end of the workshop, so if you have to go, then feel free to. But if you want to like work on this, then like feel free to stay. You can like answer questions. Also, our next workshop is going to be our guided projects. So that's I think we're gonna implement linear regression using mostly NumPy and a little bit of Pandas. But yeah, so definitely come back next week if that's something that you're interested.
Okay. Yeah, thanks, Max, for showing up.
Yeah, thank you guys for coming.
Oh, fine, the plan is fine. Yeah. So I think I went over this in the first workshop, but there's a membership portal for ACM. It's like, I think the first day Jensen posted a link in chat, but there's like a membership portal for ACM UCLA. And so the way it works is that you get points for attending events. And so at the end of the, like I think whole school year, they select people with the highest, or they have like a raffle where they have like a certain number of prizes. And so if you like have like gotten a lot of points from going to a lot of events, then you get like a raffle thing. Yeah. Oh yeah, and the patterns, like I don't know, Jensen got pretty close to figuring it out, but he didn't figure it out. But yeah, the pattern honestly to me is the more fun part, because I mean raffle is not my thing. Raffle's like the whole ACM thing. But yeah. Hopefully that makes sense. But yeah, this is just for like attendance, as well as like a raffle at the end of the year for attendance. And it applies for all of ACM. So like if you're like going to other ACM events, this also works. So like ACM design, ACM hack, anything else also. Yes. Yeah, that's nice. Yeah, maybe I didn't mention it first week. I'm not sure. I thought I did, but maybe next week I'll go over it again, because that sort of I should have went over that for sure last time. So my bad on that. I guess I'll end the recording because yeah.